Another piece of information we can get from slopes is whether or not lines are parallel and perpendicular. To think of this, let's look first over here on the left-hand side of our screen at pairs of parallel lines. What do we notice about their slopes? Well, I don't have any numbers attached to them, but what you can notice is this pair of parallel lines, they're just as steep and they're both positive. They should in fact have the same slope. Similarly with these two parallel lines, they're just as steep. They're both very steep lines going downhill. They should have both the same large negative slope, large magnitude negative slope. So basically what we have is a situation where if lines are parallel, the slopes are equal. So if two lines are parallel, their slopes should be equal to each other. That's a fairly easy one to describe. Okay? Now, perpendicular is a little bit harder to describe, but let's look at, we can see a little bit of pattern between these three sets of perpendicular lines. This one's a little bit special because if you're going straight up and down, there's undefined slope. Going straight horizontal, there's zero slope. So let's actually, I'm going to erase this one just so you don't get confused by it. That just doesn't fit very well into the rules anyway. We've got these other two perpendicular lines, and let's see what's going on with the slope. Well, first thing to notice is that here one of the slopes is negative, one of the slopes is positive. Here one of the slopes is negative, one of the slopes is positive. And I invite you to try to draw lots of pairs of perpendicular lines yourself until you convince yourself of the fact that when you've got perpendicular lines, they're always going to have opposite sign. One of them is going to be negative slope, one of them is going to have positive slope. And that's just one thing that's going to happen with perpendicular lines. Here's another thing that's happening. Here is a fairly gentle slope. This line that I'm marking the eraser over, this line I'm marking the erasing over has a fairly steep slope. One gentle, the other steep. Here one's fairly steep, one's fairly gentle. The only case where that won't necessarily happen is if they both are equally steep at 45 degrees. You might have something like this. Two perpendicular lines at 45 degrees. This has a slope of -1. This has a slope of +1. Now the way things then work with perpendicular lines is that their slopes multiply to give -1. So for example, this line here, I could picture it having a slope of say -1/2. Well, if this has a slope of -1/2, this one here must have a slope that must be positive, not negative. And it must be something that multiplies by -1/2 to give -1. 2 would work. 2 times -1/2 equals 1/2. This line has slope -1. This line has slope +1. Again, the slopes multiply to give -1. This one here has a positive slope, say roughly 1/3. Then this must have a negative slope, and it must be the reciprocal in magnitude, or in other words, -3. So the other way I phrase this, it's a little less mathematically correct, but if it works for you, what we can say is the slopes of these perpendicular lines are opposite and reciprocal. They are opposite in sign and they are reciprocals in magnitude. Okay, so that's going to how that gets applied into problems. You'll see when we talk about slope and equations of a line. Hope that helps.